over according to my clock.
We are now recording.
Okay. Well, welcome to everyone uh, to the September 29th, 2020 session of Team Zoom for Tangerine SDR and HAMSI development of the personal weather station. So this week, my big news is we shut down the Open HPSDR TeamSpeak session. So that's recorded. I thank Mike for being, I've been there 13 years doing that. Mike was there almost all that, I think. And I'm amazed how many nice messages I get from people that their Saturday morning coffee or tea was related to listening to our voice recordings. So it's like a podcast that's gone on for a while. So anyway, that's it for me. Going down the list, next we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Things are going along here, just trying to keep up with the semester, trying to keep up with the various analysis projects. For the Tangerine group, I did place the order to have a purchase order processed to get the magnetometer prototypes run. So that should be very soon on its way to Tapper, and then we should be able to get magnetometer prototypes as long as Scotty and John have agreed on things. I think, and we do have a HAMSI telecon coming up this week. One of my students, Veronica, she'll be giving a presentation on a gap seen in the RBN and whisper data at 4,000 kilometers. So she did an analysis of that. And then Carl K9LA will also be talking about retracing. W2NF, back to net.
Fine business. I did want to mention, I do have some website stuff to talk about a little bit later, but we'll get back to that. Next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Okay. Well, thank you, Dave, and thanks for running the HPSDR list for 13 years. Wow.
You were the one that asked me to do it, too.
I know. It is like, I don't think I can say thank you enough, because it really turned into a little bitty task that turned into this giant, long 13-year thing that you and Mike pretty much managed for the whole time. So, and I think I can count probably on 2 fingers the number of times you missed in 13 years. It was,
yeah, it wasn't very many.
So anyway, thank you again. If people haven't thanked you enough, because it was a great job. It was kind of sad to see it go. I just went to listen to it this week and heard that this was the last one, and it was like, wow, okay, this is like historic, because it's been going for so long, and now it's shut down. So anyway, the rest of the things this week, been working with Tom and John on the clock module, trying to get at least some beginning ideas whipped into shape. John has come up with, we hope, is what is a cheaper architecture, and maybe Tom can fill us in more on that. He's more of a time nut than I am, but John's the real time nut. But Tom is the phase noise expert. So anyway, so Tom, you might want to let us in on some of the advantages of the way John's doing it. Mostly cheap is the way I see it, and simple. So simple is good. And we pretty much resigned ourselves to the fact that there will have to be a clock module on the board. I was trying to get away with no clock module at all, but I think that that's not really going to be the case. And I think that the oscillator that we used for the HPSDR, the Crystech oscillator, that used to be so expensive, it's down to under 15 bucks now in quantity. So I'm thinking that probably the base clock module is going to have that clock on it with the circuitry from the Hermes board, only the fixed circuitry from the Hermes board, so it will work right. And that'll be our base clock configuration, which will be an extremely low phase noise, but you will have to have an external, it doesn't have a GPS, so you'll have to have an external GPS or 10 megahertz reference to lock to if you want a highly accurate frequency. So again, it won't be for a space weather station. It'll be for more of a HF receiver kind of application, but it'll be a simple low-cost clock. And the other thing that happened this week is we got the boards in for the magnetometers with, of course, with orange solder mask. Have to have orange solder mask. So we got the boards in. They're panelized in blocks of 5. So we delivered the parts. All the parts were in today. The last parts came in this morning. So next week I'm going to have a panel of brand new boards to test. So he's going to break them apart, so I'll have 5. But so I did get him to agree to build me one panel of 5 and save the other 45 boards until we test out the first ones, so we can make sure everything's good before we go and solder all our parts down. So anyway, I'll be bugging Dave Witten and Dave Larson to help me with getting the software set up. I found my boxes of Raspberry Pis, so I'm going to get the test bed set up and cross your fingers, everything works. We'll have magnetometers by next week.
Yes.
So back to you, Dave.
Sounds good. Next on the list, we have Dev, KC3PVE.
Hello, good evening, everyone. So this is a brand new Monday here in East Coast at Scranton. So we are starting our week with new energy and trying to look at our research with newer approach. But there are no exciting results right now. So we are continuing to persevere. Thank you.
Hey, Dev, your audio is a little bit low.
Okay, I just finished.
Yeah, I heard you, Dev.
Yeah, thank you so much.
Yes.
Thank you so much. So
Okay.
I was trying to say that okay, we're continuing our research with great excitement in this new week, but despite which there are no great findings right now. Thank you.
Very good, Dev. So next on the list is Bill Engelkey, AB4EJ. Go ahead, Bill.
Thanks. Tom check. Do I have?
That
Can you hear me? Okay.
you sound good. You sound like you're in a room though.
Yeah, there's a little bit of echo in here, but been focusing on cleaning up a lot of little things in the local host mainly, and so I've realized that I've as far as the radio portion, basically what I've done is I've reproduced the work of Pavel Demmin except on the Tangerine, so that's a big step. And there's a lot of a lot of other projects that he did on the Red Pitaya that are down the road a ways. So last couple of days, spent a little bit of time fooling around with GNU Radio and putting together the first vestiges of a design for how we'll make GNU Radio talk to the Tangerine. So got some ideas on how to do that, and we'll be able to test that out with the simulator. There's so many things about GNU Radio I'm not familiar with, like when you design an out-of-tree module, my question is, can you arrange to get a signal when the user presses the go button, that little green triangle that says start running the program? Because at that point, that's when I need to tell the Tangerine, okay, here are your channel layouts and everything. So, but anyway, it's got to know when to do that. So anyway, so that's another little interesting diversion. Not as high a priority as getting the local host, but since I've got so much working on the local host now, I thought I'd play around with that a little bit. We're scheduling a meeting with our computer science team for, I believe it's October 8th, whatever that Thursday is, and find out how the students are doing and coordinate. The primary thing is uploading data to the central control system. So I want to have something that kind of does that this semester. I've tested it out on my virtual machine. I can make it work for the local host side, but it's going to be quite something to get it to work to the big server at the university, because now you're talking about all the security that you got to get through, which is it's quite a high bar you got to get over to connect something to a university system. Starting out by getting signatures from our director and the dean of computer science before the OIT will even consider opening up a firewall port to that server. So, but that's going to be one of our challenges for this semester. But it's the right thing to do. So, anyway, back to net.
Fine business, Bill. And next on the list is Dan, in for XWE. Go ahead, Dan.
Thank you, Dave, and good evening, all. I am also kind of sorry to see this TeamSpeak session go away. I was the moderator for a while. I don't remember. I think it was about a year or so before Dave. And I also did a TeamSpeak session during the week on using Linux for a number of months. And I think it was probably one of the first 5 or 10 people involved in the HPSDR program early on. So I have kind of a long history with that. And as I said, I'm kind of sorry to see it go. Didn't really do a lot this week. I did get Quartus up and running on both my Windows machine, and it's actually the same machine, just a different boot. My Ubuntu machine, both of those work fine. I'm able to program into my development board without any issues. And I'm even able to compile code with both versions, both the Windows 10 and the Ubuntu 20.04 version. So that seems to be working reasonably well. Anyway, I guess that's about it. Back to you, Dave.
Well, fine business. Next on the list, we have Dave McGaw, N1HAC. Go ahead.
Hi there, all. Been really busy this week with various things, but I'm sorry that Dave Whitten isn't on. He sent me a couple of magnetometer test boards, one of which works and one of which doesn't. And I'm wondering what his intentions were there. There were no instructions with it. I presume to find out why the one that doesn't work. Other than that, I haven't done much on this, though. Listening for what the progress is, and how the clock board is progressing and things like that. The various options there. So I guess I'll go back to net. Thanks.
Well, I expect that Dave will listen to this. He had a medical procedure today, so I don't think he was feeling up to showing up here. So next on the list is Dick Patchy. Go ahead, Dick.
Okay, Dave. Good evening to the net. This is K2LCT. One observation is we had a G2 storm this weekend, and HF conditions seem to be improved. I guess I'll go into the lurking mode, Dave. Back to you.
Fine business. Thanks a lot. And next on the list is James, KG4DSG. Go ahead.
You got me here?
Yep.
Okay, I'm just lurking and listening in with great interest and really nothing to add at this point. So back to the net.
Okay, very good. And next on the list, let's see. The list is shuffling on me, so that's what's taking me a minute. Jay, WB8SBI. Go ahead, Jay.
Okay, good evening, everybody. Bill Gates is stopping my camera from working at the moment, so don't worry about that. Nothing of big interest here. The only thing technically wise going on is for some reason my Ham Radio Deluxe logbook and something changed in Windows and it doesn't work now. I keep getting an error that says the system is not configured to handle this, and I've never seen it before and it was working fine. So I'm troubleshooting that. Otherwise, just here to enjoy the company and maybe learn a thing or two tonight. 7-3 to all. Hope you're all safe. Back to Nick.
Fine business, Jay. Next on the list, we have Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't have much to report. I've been busy with homework. I'm working on some of that now. I am interested to hear more information on the clock modules, if there is any. Back to the net.
Okay, well, once we get through the list, we'll check on that. So next on the list is Michael, AA8K. Thank you, Michael, for all the time with me over the years.
Well, thanks, Dave. Greetings to everyone on the conference, and back to you, Dave.
Fine business. So next on the list is Tom, N5EG. Go ahead, Tom.
Okay, thank you, Dave. And Dave, thanks to you and Michael for all your work on TeamSpeak. I listened to the recordings after the calls for quite a few years, and that really got my interest going in SDR. So it was a terrific run there. So thank you, both you and Michael, for all the recording. That was great. Let's see. We've had a bunch of emails with John Ackerman on architecture for the clock module, and John did about 6 measurements and then left town. And so he gave us the emails and said something like, make heads or tails out of this. And so we're still trying to do that. What John's trying to accomplish is to reduce the cost of the clock module without severely degrading the phase noise performance. And so he's looking at, are there ways to do that? And we can talk about that during the open session here. And then a quick comment about GNU Radio. Bill, I don't know if you're aware, when you run GNU Radio Companion, it generates a Python file. And the default is called topblock.py. And that's actually an executable Python program. So you don't have to run that from within GNU Radio Companion. You can just start that from a command line. It'll bring up the GUI, it'll run everything. So perhaps that's an approach you might find to how to start those things up. And back to group.
Well, fine business.
That is interesting potentially for Christina at Case, because she's looking, and I think Nathaniel too, looking for ways to take wave files and convert them into digital RF. So a single command, boom, and you got it. So
yeah, you could. Yeah, there's. I think you can pipe things in and out. I'm not sure, but you can at least run the program.
Yeah, Bill Lyles gave us he dug up a very, very well vetted GRC for taking wave files and converting them with verified IC content or IQ content, and better than what I could come up with. So we're going to work with that a little bit.
Okay, I think GNU Radio blocks can take named pipes as input and output. So you can use those and pipe from the command line, I think.
Well, we're done with the introductions, and we're open for general discussion.
Yeah, so Dave, I have a quick question for you. On the Raspberry Pi setup for for running Dave's code,
yes,
on magnetometers, how should I set up the Raspberry Pi? Is it just load Ubuntu off of an SD card is sufficient, or what?
Yeah, you're going to just need a C compiler, and there are some IQC, IQC, I2C, sorry. elements that you need to set up or check on first. And so you'll be using the standard Linux list devices kind of thing for I2C devices.
Okay, but as
So
far as
those
the
are really
OS,
the only
I would
two
just-
things you need. And both the Odroid N2 or the Raspberry Pi have the commands. They differ slightly between the two systems.
okay, because I have an Odroid N2 that I think is all set up to boot off of eMMC, I think is what it
Yeah.
boots off of. So that's all set to go. So I just have to download Dave's programs from his GitHub account.
Yes.
And
And he's tested them on both. And I would think that Dave will answer emails this week. So I don't.
okay. Well, I probably won't get the boards in time. I may get them this week, but it might not be until the beginning of next week because we just gave him the parts. So he's going to go through, audit the parts kit, and then he's going to hand place the parts, but then he's going to reflow the boards, reflow a panel of them. So I don't know how long it'll take him. It depends on who's ahead of us in line. So, but I just wanted to get ready, you know.
I have an N2 running that code, and I started it in late June, and except for the reboots of the required by the operating system, it's been running since June till now, and I have had no crashes.
Okay, and Dave's code's Python, right?
No, C.
It's C, because I want to know.
Straight C.
I'm probably going to have to change the addresses, but that should be
But
all.
they're all command line switches.
Oh, they are. Okay.
So just go to his GitHub. Do you have the GitHub
I
address?
don't think I do. I think I've been there, but I don't think I wrote it down.
Well, if you go to the plug for the Tangerine SDR website,
Okay.
if you go to the magnetometer page, the GitHub is at the bottom.
I will go there.
And I wanted a few things about the website. So I am a co-host, so can I share, Nathaniel?
Yes, you can.
Okay. Just a second. Where'd I go here? Let me, I've tried to get, okay, Chrome. Share, but I'm on the wrong page. There. Okay. Changes that I've made. We now have project status, and this is my best guess at the current status. If you hover over the names, you get a tooltip. If what I'm wanting to do is when things are done, I want to put a date on the done, and these are my guesses at that. If there is no information in these, then there's no tooltip. So that does that. And if you click on the magnetometer, it goes to the magnetometer webpage. Now, for every project that's kind of active right now, there is a magnetometer webpage. There's an introduction. I went in and pulled the video and the slides from the DCC and put them in here for each project that had one. So you can go and check those. I've also put links to the documents, the current documents that are relevant to this particular project. Dave had some pictures and the software is here. So this GitHub site is his. Now, Scotty, for the data engine, we have that.
Okay.
So I'm going to need some text or information about the data engine when you have something. I don't even have a design document that I can pull things out of.
Okay.
So whenever you're ready, we can add something. RF board, Tom did a nice job, so I had that stuff available. And I even have one for Nathaniel, so he can put stuff there. Probably easiest way is just to create a text file and send it to me, and I can add stuff.
This is for Jonathan, you mean?
Oh, Jonathan. So for the low frequency board. So we have
Yeah.
places for all the regular boards. This is what I have right now. There is a location for the localhost bill. So this is where I'm putting localhost stuff. I haven't really figured out what to put in single board computer. So it's kind of a placeholder. And I did have links for data aggregator, which is the information about what you were just talking about. A place that would collect data from the single board computers and any kind of reporting services we have. We can redesign those, but generally it's the projects.
You need to check the spelling on aggregator, I think.
Yes, it's probably wrong. Yes, it is.
Yeah. So, Dave, how do you want to handle the difference between the Pi Hat magnetometer and Dave's prototype magnetometer? Should we
Well,
just
right now,
or do we want to combine them?
I think we'll combine them because it's basically the same design. And this we'll just call a prototype. And then once you have a picture of the other one, we'll start filling in more information.
And hopefully the software is identical, so
yes,
we can make it identical. So
yeah, the only thing that Dave was worried about was the I2C port numbers.
Right.
And he has the code defaults to 1920 and 21 or 22. I can't remember.
22, I think.
But I'm using the single board one, and it used 1A. And the confusing thing is the C code does not, it only takes decimals. It doesn't take hex numbers. So you have to convert 1A into 28. So like everybody knows that 1A is 28, right?
Or 26, right?
I think it's 28. Oh, it's 1C. I'm sorry.
Oh, okay. Yeah, 28.
Yeah.
Okay, so when we get the numbers are on the schematic for the Raspberry Pi version, and I don't remember what they are. I think it's 18, 19, and 22 and 23 or something like that. So it's a little bit different.
As long as you're below the crossover point, then
yeah,
there's no problem.
I want to make them different but not overlapping so that you can tell which board you have plugged in. That was kind of the idea.
Scotty,
so I think it should be no problem. And it's just a simple compile. So if you have Raspberry Pi or an Odroid, you just download the code and then you do a make and just a make, and it'll do it. Okay. Then it's the switches. Dave down there, David's used that software, haven't you?
Me?
Yes.
Yes.
So it's not very complicated. The complicated part is learning all the command line switches.
If I remember right, I saw a document on his GitHub that listed all the commands.
Yes, it lists all the things, and there is one command line that will give you the current setting of all the switches.
Oh, okay.
So, and there's a couple of things, corner cases, where if you use two commands, I've seen it blow up if you use two commands that weren't intended to be used together.
Okay.
But we're trying to catch those and make them not possible.
Scotty, thinking back to earlier this week, I actually installed a real-time clock on my Raspberry Pi, and it uses an I2C interface. So I learned a few interesting things about Raspberry Pis. and I2C, so I can probably help you.
So which
We're
interface
stuck on
does it
something.
use? Which is it?
It's the 3231 or 31 DS 3132 was just an El Cheapo. It's actually the one that came in the kit that I bought from Bud Churchward.
Oh, right.
He included an RTC in it.
But which
So
pin does it connect to? It connects to the expansion connector, right?
right. It connects to pins 1 through, see, it's 1, 3, 5, and 7.
3 and 5 are the two pins that are.
Yeah. Yes.
You know what I2C address he uses?
I do not. I mean, the clock uses 66 as
Oh.
its I2C address.
Oh, well then we're covered. It'll be interesting to see if it plays with the Tangerine SDR clock module or magnetometer module.
Yes.
Yep.
I think Dave was telling us, I think the default is 400 kilohertz for the speed of the
Yes.
port. So, and is Dave using 400 kilohertz or is he slowing it down?
He tried to do it at 100 because he was concerned about the speed of the long run. Because there were timing delays such that if you didn't do that, it tried to read the value before it actually made it back.
Because of the length of the cable and the delay?
Yes.
Yeah.
Yes.
So he did run it down to 100 then rather than 400.
I think it's default 100, but I know Jules has been experimenting with changing those values. So I do see we have Home and Kim here too, so came in a little late.
Oh, hey.
Hello.
Yeah, I had a lecture until like 9 o'clock ish, so yeah, it's not a perfect time for me to join. But I have a little bit of update if
go ahead.
So well, first of all, in Jenny Jump, we ran the Bartington, the flux gauge magnetometer, and our magnetometer together inside a solenoid coil to compare the signal. That was our intent. It took us a little bit of time because, first of all, we found our own problem, our data acquisition system, not ours. I mean, the NGIT data acquisition system. So it took us a while to fix that problem. Then we ran it for a couple of days. But what we have found is that the Raspberry Pi magnetometer didn't really go too long. I think we only have like first hundreds of data points and then stopped, and then it filled with all this not a number. So I'm in the process of looking at data again just to make sure that I ran the magnetometer properly. I don't know why that happened.
Okay.
But anyway, we're very close to to being done to compare those two magnetometers. So well, we keep working on it right now. Gil is also working on it. Other engineers working on it. So I'll try to give you an update as soon as we found some improvement.
Well, sounds good.
Dave, if we could go back to the web page.
Oh, sure.
I'm noticing there's discrepancies on the clock board. We're calling it like 3 different things, and we probably need to decide on what it's going to be called.
Because CKM is supposedly the official title for clock.
Yeah, because we call it clock module. I've seen it timing module and GPS. So.
Okay.
We
So
should
I'll go
straighten that
through,
out.
and the verbiage here is out of John's document from the documents directory.
Yeah, I do believe its primary purpose is the clock, secondary is time.
Yep.
And adds GPS if you want accurate. So.
Okay, so I'll work on that a little bit.
Yep.
did you see other pages that call it, or are you just referring to this verbiage? David?
When you on the front page, you have it as GPS.
Okay.
Then when you click on it, it's timing.
Oh, here. Oh, I'm not sharing. Sorry.
Oh, I see. It says GPS board in the table on the module page.
Right.
And then when you click on GPS board, it says timing module. And if you go to the project components, it says timing module. And if you click on that, it takes you to the timing module. So that's consistent. But
yeah,
I would kind of like to say, maybe you want to say clock/timing module, and then in parentheses put CKM after it.
Okay.
And then on the RF module, put RFM in parentheses after it. And on the data engine module, put DE in parentheses after it. So we got the abbreviations that are always consistent.
Okay.
That might work.
Yep, that helps.
Yeah, I know. I feel your concern, David, because I know when I first started my first job, I still remember it was with an IBM compatible company. They made node controllers, and just learning all of the acronyms that IBM used it was just like totally daunting. You come in there as a new guy, and they talk about these things, and they use different terms for the same pieces, and you're supposed to know this, and it's like you don't know this, and it's just totally confusing. So even just marginally different little nomenclature can
Well, that's how you keep out the riffraff.
So if you guys put stuff in here where you're posting these documents, that's where I've been grabbing text that explains what this component does.
Okay.
And if you want, I can, this, all this text in these boxes is simply a JSON file. So it's very easy to update and change for me.
Yep. You see there, it says GPS board, which
Yes.
is confusing.
So I'll fix that.
Good.
But I do have them linked so that if you click on it, it goes to the right place.
Yep.
and Dave, you know what's going to happen is you're going to have CKM/GPSDO, and you're going to have CKM/basic, because there's going to be two of them eventually.
Okay. So we'll add the other one, but I have no information about the other one. So
Right. Well, when we get there, there's going to be, what kind of module is it, and then which one of the modules is it?
Right.
I'm expecting there's going to be several data engines. I know there's going to be several RF boards. We already have 2 magnetometers, so.
So I did want everybody to see I snarfed the DCC slides and the individual videos for these particular boards.
Oh, is that under meeting videos? Is that where you have the?
No, this is only on each you go to the module components, and right here you can either start a video on, and I'm not going to subject you to it, but there's your slides.
Okay, go back one again.
So it's.
Oh, I see. Okay, got it.
In the data engine. That's only official information I had available to provide to people.
Okay, I can give you a little bit earlier talk that is an informational talk on the data engine as opposed to a status talk that one is.
Right.
But it's 45 minutes long, so I don't know if you want to deal with that.
Well, I mean, we have the other informational talks that are here too as well, Scotty.
Yeah.
So I'm trying to make the content as up to date as possible. But it's two things. It's a manual, or kind of what are all the pieces and how do they work, and the other part is where are we in each of the pieces.
So I'm guessing what we're going to want to do is on that first page where you have all the working documents, as we get as we complete pieces and write ICDs, all the documents for that will go out of here, and they'll be moved over underneath the particular module that they apply to, right? Is that your?
Well, these are working documents, and it was a place, although I think only Tom and you and I have upload capability.
Yeah, and I don't think I have even a data engine document in there, but
there isn't one.
But
And
we
then
have
we do have a subdirectory that has the old documents.
Yeah. But I think it's going to want to be a place where you can go to look at the ICD for the data engine and the ICD for the RF module and the ICD for the clock module.
Right.
And you're going to want the latest and greatest one that you want to use to design your own clock module or whatever you're going to do.
Most visitors are not going to want to immediately dig into these documents. So I'm trying to sort them in a way that they'll go to a module and then find more information.
Yep. And that'll be, so there's a place for them once we get them.
Right.
Yeah.
Now, right now I have the project leaders labeled. I assume that if you have people that are doing substantial work, you could identify testers or programmers or other things, people who help on the project if you want.
So we can add that below project leader then, if you want.
Right.
Okay.
We could put in team members or what they were doing, programming.
Testers, assemblers.
Yes.
Additional designers or whatever. Yeah.
Yes. So like the magnetometer has more people than just Dave, and we should include all those people. So, but I did make progress since there were suggestions last week, and I want to make sure that you guys also.
I want to take some time to go through it and make some comments to you and on my opinion.
Yes.
So you can throw them out or listen to them, whichever you want.
Well, I like to take as many pieces of input as possible.
I think it's looking really good, Dave.
It is. It looks great for a organizational point of view. It's much better.
Yes. Well, and it's a lot of the feedback that I got last 2 weeks on Zoom that helped.
The only thing I can think of is that I think on the modules, I'd like to say, okay, we're going to have data engine modules, we're going to have RF modules, we're going to have clock modules, and then we're going to have a single board computer. Because the very low frequency board, well, actually, that's not true because the VLF board is not going to be an RF module. It's going to be a leaf module.
Yeah, and should I put that? I have it board. I should probably call it leaf.
Yeah, so.
And then the magnetometer isn't really either.
It's kind of out in limbo land because it's a pi hat. So it's sort of, that would go under a leaf board. I think it'd be leaves and hats would be.
Okay, I'll put leaves on VLF and magnetometer.
Yeah. But then, of course, Dave's magnetometer is not a hat board. So now you run into that problem. So, because but it's a prototype. So maybe you get away with that because you say it's a prototype.
Yeah.
And it connects up with cables, right? So.
Well, I mean, the way I'm doing it is I have one of those breakout pi hats. Right. And then just run a connector wire over.
So it looks like a hat then when you're done, when you hook it all together.
Yes.
Yeah. So it could go under pi hat leaf boards then.
Yeah. So I'll do that.
Yeah, sounds good.
Anyway, I want to leave room for other discussion.
Yeah, when I saw the boards today, and I'm not really that impressed with the orange solder mask, because I thought it would be a little brighter. It's kind of a dull orange, but it'll
be distinctive color.
That's right. I mean, you gotta have like fluorescent orange. That's what I really wanted.
Oh, it's an autumn color.
Yeah, but it doesn't look bad, and it looks different than everything else. So I don't
Yes.
think I've seen a board with orange before. So that's one thing we got going for us. But
Do you
what
have one you can show us?
I don't. They're in panels and they're at the manufacturer. But by next Monday, I should have one that I can show.
Okay.
And I don't even have one here. I don't have any parts here. They're all over at the CM. But what the CM said was that if you order, and he said, was it black, green, blue, and maybe white. There's 4 colors that are standard. And he says you go any board manufacturer and those 4 colors look the same. But when you get to orange and purple and these odd colors, he said you get whatever that manufacturer has for that color solder mask. So with orange, depending on which board manufacturer we go to, and I'm expecting like the data engine might be a different manufacturer because this is a 2-layer board. The data engine is going to be 10 layers or some. So it'll likely be a different manufacturer, board manufacturer, so we may get a different color. But, well, it's still going to be distinctive.
Well,
So,
as long as it works.
as long as it works, yeah.
That's more important.
And the orange, that makes it work a lot faster than
Yes.
the standard. So yeah, I should have said if I could steal a board, but since they're already in panels of 5, he didn't have a spare panel to give me, so
yeah,
I couldn't take one. But it does look pretty nice. It's amazing, when you see it in real life now, it's really small. It's only, it's like a half hat.
Oh, okay.
Because it's only half as wide, half as tall as a regular hat board.
Yeah.
And hat boards are pretty small already, so it'll be interesting to. And he was impressed that we crammed all that stuff onto that small of a board.
Well, that's good.
Even though about a third of the components are not installed because they're extra connectors for things that we don't use.
Mm-hmm.
So, and the P&I parts are not here yet, but they'll be here by the time I get the boards assembled. So
Okay.
they've all been ordered. So
well, and some of us as testers have at least one.
Yeah. And of course they come without headers, so I get the fun joy of soldering on 100 headers, actually 50 headers, because we get 25 of them. So
yeah.
Mm-hmm.
I don't know how we're going to do that in production because, if we order 1,000 of these, are we really going to want to? Somebody's going to have to solder 500 times 2, 1,000 headers.
Well,
yeah.
You order boards from Adafruit, and they give you 2 headers in a bag with the board.
I have no problem with the headers. I can buy them for 7 cents, but I got to solder them down, or we let the user do it.
Yeah, that's what Adafruit does.
But there may be some people who really don't want to solder. So
We'll have them pay a fee, small fee.
Hey, how about $44? Oh, wait.
Yes.
I still haven't figured out why P&I charges $44 for soldering 2 7-cent headers on the board. That seems,
They're trying to discourage it.
Yeah.
So the headers aren't something that can be placed automatically like the rest of the components?
No, because they're soldered on the P&I boards, not on our board.
So the P&I boards are already made.
Yeah, and our board, we're going to have the female headers soldered on.
Okay.
The male ones on the boards that you buy, it comes without them. So.
And so you're saying that P&I will do it for you for $44?
Well, they have a version that has the headers that's $64, and the one without the headers is $20.
Mm-hmm.
So hey, I can solder 50 of those on in an hour easy. So
yeah.
I'll just do it.
And it's not small dimensions; those are big.
Those are big. It's 10th-inch headers, so they're easy.
Huh.
If my scouts were still meeting, that would be one meeting of having them solder, but they aren't. So.
Like getting Girl Scouts to scrub floors and wash walls. That's what it feels like. And then guess what we did in our scout meeting?
Yeah. No, but these guys like soldering, so that you could probably con them into doing it pretty easily.
It's a transferable skill.
Yeah. And they all know how to solder, so we've ensured that they know how to do that, and they're pretty good at it too because.
Put correctly put the coax connectors on. There's
Yeah.
Yeah.
the skill.
That and replacing backup batteries in HTs, where you have to disassemble the whole radio. So it's not for the faint of heart.
Yeah.
So Tom, are you still there?
Yes, I am.
Yeah. So could we talk a little bit about the clock module for the benefit of everyone else, or do we still not know what's going on? I know I don't. So.
John did what I call quick look measurements, where he had a messy test setup, and he asked a couple of questions. Can I grab the screen here? I can try and put some of the diagrams up.
Yeah, it should be good. Go ahead.
Okay. Okay. Can everybody see this?
Yes.
Okay. So this was John's idea for how to reduce the cost of a higher performance clock module or CKM module or GPS module or whatever it's called. And the idea that he had was that there's two sockets here. You would only populate one of them. The bottom socket here would be the dual channel GPS module, and the upper one would be the single channel. And so you could install one or the other. And then the timing output clock at 10 megahertz or whatever frequency was chosen would go into a Silicon Labs dejitterizer component. And what the dejitterizer does is dejitterizes the clock, so it removes jitter. These are basically, I think they originally were telecom dejitterizing components, where they removed systematic and periodic jitter from telecom signals to produce a clean clock, and they've evolved since then. This particular module uses a crystal, an external crystal, to dejitterize. And so with this particular circuit, John hooked it up quickly and made some measurements. And let me see if this will screen switch here and work. Let me. No, wrong. I've got to pull from about 100 emails here. Okay, so this was the first result that he made. The blue line on the chart is the phase noise coming out of the dual channel GPS module. And as you can see, the phase noise is pretty high coming straight out of the GPS. And then he ran that output through the dejitterizer circuit. And the pink line is the phase noise of the clock coming out of that. And again, this is the loop bandwidth on the dejitterizer. He selected the 0.4 hertz loop bandwidth, but the design tool tells him that at the frequencies he's chosen, it would actually be about 278 millihertz loop bandwidth. And the frequency is 30.72 that he selected. And so you can see it does reduce the phase noise quite a bit. The cautions that he has is his test set here, his reference has a phase noise of minus 145. And so this is a quick test. This is not a thorough test. And secondly, his test setup was single-ended clock signals, not differential. And so he thinks there's some systematic error in the measurement results that he has. And so this, again, is a quick look. It's not really any kind of a real look, but it's sort of a proof of concept. And then the...
and this is using the dual frequency?
This was using the, yes, that was...
F9T.
Right.
Yes, that was the dual frequency.
Yep.
So the other thing he measured was the Allen deviation of the clock coming out. And you can see the the F9T 10 megahertz Allen deviation in blue, and the Allen deviation of the dejitterized clock in pink. And I saw a very similar result when I put in a 10 megahertz rubidium into a different version of the dejitterizer, the 5344, that when I got the loop bandwidth down below about a hertz, I saw the Allen deviation increase significantly. And I've explained to myself why that is, and then explained to myself why I'm wrong for 3 or 4 different explanations. So one possibility is that the untemperature compensated 48 megahertz crystal on the dejitterizer board is kind of noisy down in that 0.1 to 1 second time range. And so we may, in fact, need a TCXO on the dejitterizer part rather than just a raw crystal with no temperature compensation. But the results were interesting enough that John's going to go cogitate for a while and think about ways to cut the cost of the clock module and still achieve a reasonable phase noise and reasonable Allen deviation. So these were what I call quick look, meaning that he had 8 hours to go set it up, make the measurements, pack it up, and head off on late summer vacation. So I wouldn't trust the results right away.
Could you go back to the schematic?
Okay, I've got to go find the schematic. Let's see.
Yeah, and you can see there's a mistake there. I drew this, so
right.
The PPS down here should be connected to the 10 megahertz on the bottom of my oscillator. That's incorrect. It's the 10 megahertz. Right. Time pulse 1's 10 megahertz. Time pulse 2 is the pulse per second. So you want to feed obviously 10 megahertz into the clock generator, not 1 hertz. So.
Right. The thing that I noticed is that the lower of the GPS units, you have it as F9P and not F9T.
Yeah, now, I don't know about that, Tom, because he told me F9P. Is that not right?
Well, there are 2 versions.
I know, and
I believe. The P is the position version, T is the timing version. So
the diagram that he sent me.
Make a note to check that anyway.
Yeah, okay, you're right, because
I think either one will work. It's the T is the preferable one though.
And all the other diagrams have T in them, so I don't.
Right.
Yeah. So yeah, this was something Scotty did very quickly off of the back of the napkin.
Yep.
So it's got the appropriate napkin marks somewhere if you look.
Yep. Yep.
Yeah.
I just thought I just wanted to flag that.
Yes,
because the plots you were just showing were F9T. So.
Yeah, yeah. So the let me see if I can draw here. This crystal here is on the eval board. That crystal is a 48 megahertz, just 4-leaded package. It's not temperature compensated. It's just a crystal, and we think that may be the cause of some of the issues.
Yeah.
Allen deviation.
I'm sure John will think of this, but you can just stick a cover over it and see if it changes.
Yeah. So anyway, he wants to take a look at that.
You could feed a TCXO into XA or something and get better performance, maybe.
Yeah. By the way, this is the same type of chip I was talking about in last week's conversation about dejitterizing the clock to the VLF ADC.
Yeah, so about a year ago, I measured the 5344 chip, which is the 4-output unit, by feeding in a rubidium and then measuring the transfer function of the oscillator.
Yeah.
And that definitely showed the Allen deviation peaking at lower loop bandwidths.
Yeah, the Silicon Labs is not the only kid on the block here. TI and I think was it Maxim? A number of different people make these So we might find one that's more suitable.
Right. Yeah, John, we picked these because we had evaluation boards available.
Right.
For making the measurements.
Oh, well, it's very good for a first pass and show that it helps, but it has some issues.
Yeah, absolutely. So the phase noise, we've had a couple of discussions. The primary concern with jitter, of course, is the impact of sensitivity, because the higher the jitter, the worse the high frequency sensitivity. The ADC chip has a spec of about 500 femtoseconds, at which point the 30 megahertz sensitivity is already rolling off a dB or so. And so it's a concern that we need to have sufficiently low jitter feeding the 122.88 clock.
Where was the hump, shall we say, in the Allen deviation around a second?
Yeah, in the ones I measured, it was around a second. Let me see if I can, yeah, this one here. So this was with a 0.4 hertz loop bandwidth, which the software says comes out at about 0.27.
Right, yeah.
And so, and you know, the Allen deviation plot just makes that stand out right away. The clock builder software tells you that if you're using that bare crystal on the module, to not set the loop bandwidth that low. And so, and our two independent measurements seem to confirm that as pretty solid advice.
Was this a little chip crystal, I presume?
Yeah, it's a surface mount crystal. It's a ceramic package with pads on it.
The larger crystal might be less noise too.
Yeah, yeah. So we, John's going to probably experiment with a couple of the different crystals. He had to do this, make the measurements and pack it up for 3 weeks.
No.
He'll be back in 3 weeks' time.
No, well done for the time allotted.
Anyway, so that the idea here is to get rid of the FPGA, to get rid of the super expensive VCXO, and
no, just
cut the cost while still using.
If we don't, just before we get off of this, I'm a little confused because I see a 5328 on the schematic, but a 5342 is what you're talking about the results of. Which one's correct? Are they both?
Yeah, this was measured with a 5342.
Yeah.
He doesn't have a 5328 board yet.
But that's what he's thinking of using, you're saying?
Yeah.
Got it.
I think, Nathaniel, are you going to be getting him a 28 board?
That's the one he asked me for, right?
Yeah.
Yeah, we placed the order today, so it should be.
Okay. So by the time he gets back, he should have it, right?
That's right.
Okay, cool.
Yeah, I spoke with him I had a nice chat with John on Saturday morning this weekend. So he went over a lot of this stuff with me and we talked about it. So I'm quite excited about this.
Okay.
Yeah, if we use the 5344, then we could skip the external buffers and just drive the clock's outputs directly.
Yeah, that's a good point. That helps.
Yeah.
Yeah, so in this one here, I think we really need 4 outputs.
We do.
And so the 28 is only a 2 output part. And as Scotty said, the 44 is a quad output. I was able to, with the 5344, come up with certain frequencies that I could drive the part nuts with. And generally, if you pick frequencies such that the internal dividers are large and relatively primed to one another, you can really blow up the Allen deviation performance of the oscillator. So, but I think in practical use that's unlikely. It's just being a little devious and picking the magic frequencies that'll drive it crazy.
Well, hopefully 122.88 is doable without.
I hope so. Yeah, I hope it's not one of those ones. I picked out strange ones like 10.37695 or something. I don't remember exactly what it is, but you could pick ones that gave it pretty poor performance. Okay, let me send it back here.
So I think we're about at time, aren't we, Dave?
Yep, we are at time. I was wanting to give everybody a chance if they need it.
Yeah, so Nathaniel, this is like the end of your killer week, right? Monday nights?
Yeah. Yeah, I was telling Dave before, I was like, I don't know, by Monday nights I'm just like done, but because I've been using like the weekends to kind of prepare for class and prepare for the week. But we're making it.
Nathaniel, it gets better, easier as you go through your career.
That's good. And
The problems get bigger.
Oh my gosh, I know.
So Dave, is that your workbench behind you there?
Yes, I need to clean it up.
Looks awesome. Yeah, workbenches should always have at least 3 layers of stuff on them.
Well, I've got a couple of oscilloscopes and a bunch of other stuff there. I keep meaning to start cleaning it up, and then I make piles on every other bench.
So you just move it around. That's all that happens.
I cleaned up my desk one time, my workbench, and found a laptop that had been missing for 2 years.
And then all the other stuff that was on it you couldn't find for the next 2 years, right? Because you put it all away.
Yeah, that's right.
Yeah.
I actually know where pretty much everything is until I start moving it around. And then
yes, that's it.
Did any of you guys know Bob Pease?
Oh yeah, I met him. I had lunch with him one time when he came to Aerofest in Arizona.
Yeah, I'd had lunch with him at one point. And it
was a character.
His office and his Beetle looked alike. Just stuffed. But of course, he was well known that if you ask him a question, he'll just go to a stack, go down through it, pull the paper right out.
Yeah.
Well, I had lunch with him when I was designing a mixer for our field day station. And I was having trouble picking the op amp to use because, I mean, there's 10,000 of them, right? And it's like, well, what parameters are important? So I thought, oh, hot damn, here's Bob Pease. I'm going to go sit down next to him at lunch, and I'm going to pump him for info, and I'm going to get the answer to my question, which op amp to use. So I sat down and I asked him the question, and he says, well, you know, they're mostly alike, so just pick the right ones with the right features, right parameters. And that was it. That was the answer I got. So, needless to say, I was a little disappointed. Thought I was going to get, you know, fountain of knowledge, and instead I got kind of an offhand. Well, it really doesn't.
Well, I think he was rather ho-hum about op amps, but he could get really involved in transistor characteristics.
And also, what was it? The references that he used to use. What did they call those? There's a name for them that are high precision voltage references made out of silicon junctions or germanium junctions or some.
Oh, the band gap.
Band gaps. He was just a Mr. Band
reference. Yes.
Yeah. He wanted to talk about band gaps all the time.
Well, it is a pretty remarkable bit of physics that makes them work.
Yeah, yeah. And I mean, you heard what happened to him, right?
Yeah.
He's actually his buddy, I think his name was Jim.
Yeah.
The other infamous guy at National, right? Well, he passed away, and Bob went to his funeral. And on the way home from the funeral, Bob ran off the road in his VW bug and crashed. And
he had a heart attack.
So that's what they think happened?
Yeah.
Yeah.
Yeah, they think he had a heart attack on the way leaving Jim's.
Yeah, because he came up to a key intersection and he just never stopped and went right through. So
Right. Yeah, I'm trying to remember Jim's last name, but yeah, he was another
That was Jim Williams.
major guru. Williams, right?
Jim
That's
Williams.
what I thought. Yeah.
Was he another national figurehead crony that they had?
Yeah, yeah,
National?
he was a terrific analog designer.
Yeah,
Yeah.
I mean, they just kept these guys around because they were so good at what they did. They just make a position for them because they wanted to keep them.
Yeah, I would highly recommend if you have a chance to read some of Jim's application notes. They're wonderful. Application note 45 is my favorite one.
Which one is that?
Well, actually, that's from Linear Technology.
Yeah.
That has a bunch of different circuits that Jim was working on. And I think it even has pictures of his baby's heartbeat seen on his oscilloscope, his son's heartbeat from the womb.
This is this is Jim Williams, right?
Yes.
Yeah, okay, got it up here.
Yeah, he was with National, started at MIT, Philbrick, National, and then Linear Tech until he passed away. And what's the book you were just talking about?
Application note 45.
Oh,
Yeah, Jim also wrote several books called the Analog Design Cookbook.
Right.
One, they were published by Electronics Magazine probably 40 years ago. And those are real, I've got a couple of them, they're real collector's items.
Yeah, how about Bob's book? He had was it on analog circuit design? He was an expert on debugging.
correct.
So he had a book that had a picture of his desk with this mound of wires on it, and it was some test circuit he was working on that was interconnected amongst all of the other test equipment and wiring and junk. So it was,
Yeah, he was a master of 3D prototyping.
yes. And you know, just like your bench, Dave, if you need to work on the next project, just walk up to the bench, you just push everything back, make a little spot, and then the stuff in the back just kind of piles up higher and higher.
Higher, yes.
Kind of like the Rockies.
Well, I have a bench in front of me that's computers and my HPSDR stuff.
Fortunately, we can't see that one, right?
No.
All right, gentlemen. Good night. I'm going QRT.
Okay.
Yeah, I think I need
All
to
right.
go QRT also.
Yeah, I
Thank
think
you.
so.
Sounds like a good idea.
Thanks for that app note, Jonathan.
73.
Yeah.
73, everybody.
73.
73.
73, bye-bye.
Bye.
Bye.
Hey, Dan, you want to stay around a minute? If you're there. Hello, Dan, you're muted.
Yeah, I'll stay around for a minute.
Dan, I have a quick question for Dan, then I'm going to go. But Dan, I have a situation where I was looking at a piece of code and I was trying to compile it on a Pi, and it looks like it hasn't been compiled since 2016 on the GitHub. Is the newest thing is 2016, and it crashes in C11. The guy's trying to kind of a standard thing that people do is they take a pointer to a string and put it into an int, into a pointer to an int. And the compiler is complaining about it. I always worry about these things because it all depends on the architecture, whether it works or not.
Yeah, that's true.
But surely you've run across a few of those before,
Yes,
haven't you?
I have. What I would, do you know what sort of error code it gave when it exited compile?
A little bit. It was earlier today that I tried it, but
Oh,
I could
okay.
send you the output, and I
Yeah,
could send you the
send me the
details.
output.
I
I'll
would
take a
like
look
to
at
just
it.
know. I mean, I know how to generally how to fix it, but I don't know if the code will work the same way as they expected it to.
Yeah. What is it?
It's WS Perry Pi.
Oh, okay.
So this is the stuff that we're using on the Tapper boards, but I was
Yeah.
going back to compiling that and looking at it, what it does. And I don't know. Bruce got it to compile somehow. Bruce down in Alabama has got
Yeah.
it.
I'll be darned.
Anyway.
Okay, yeah, send it to me. I'll take a look at it and tell you what I think.
I'll do that. I'll
Okay,
73.
great.
I'll talk to you
73.
later.
Good night, Dave.
73, Dave.
Bye.